Welcome back. Today we're going to talk about addition and complement rules. This first half of the video is just going to be about addition rules. Addition rules have to do with adding probabilities to find out the probability of having one event or another. And so when we start to talk about addition and complement rules, we need to talk about mutually exclusive. Mutually exclusive events are events that cannot happen at the same time. So you might say a mutually exclusive event might be drawing one card from a deck and drawing a king and a 5. Well, those are mutually exclusive because if you only draw one card, you can't do both at the same time. Okay? So, for example, another one would be if a die is rolled and an odd and an even number show up. Well, that can't happen, so they're mutually exclusive. Together, they exclude one another. Okay, so we're going to consider the fact that there are two events actually going on here. Event A is the event that an even number is rolled. Event B is an odd number is rolled. When we talk about those mutually exclusive events, the probability of A or B happening would be the probability of A happening plus the probability of B happening. Okay? And so what this is going to equal is you have a 1 out of 6 chance of rolling, like, say, a 2, but you also have a 1 out of 6 chance of rolling a 4, and you have a 1 out of 6 chance of rolling a 6. And so the total probability of the probability of A, which is an even number, is going to be 1/2, because the probability of rolling an even number on a 6-sided die would be 1/2, because half of the numbers are even. Well, the probability of B is going to be 1/6 plus 1/6 plus 1/6, because you're rolling a 1, a 3, or a 5, and so that's also going to equal 1/2. And so the probability of A or B happening, odd or even, is 1. You're going to roll either an odd or an even number. So that's how mutually exclusive events work. And so when we look at a deck of cards, the probability of picking a 5 or a king would look like this. I'm going to go ahead and say this is event A and this is event B. Well, if we look at A, we can have a 5 of clubs, and I'm going to attempt to draw a little club here, okay? Or we could have a 5 of spades, and I'm going to try to draw a spade here, okay? So that's my attempt at a spade. Or we can have the 5 of diamonds, so we can have the 5 of diamonds, or we can have the 5 of hearts, okay? So there's four possible outcomes for picking the 5. The same goes for the king. So we can have, and I'm going to stick with the red here, we can have the diamond king. We can have the king of hearts. We can have the king of spades. Or we can have the king of clubs. Keep wanting to draw that 5. Okay, so we have 4 of each of those. So the probability of picking either one of those, they would be things that are not, they're mutually exclusive. Okay, so if you pick one, you cannot pick the other. Okay, so the probability of picking a 5 is going to be 5 out of 52, 4 out of 52, and the probability of picking this is going to be 4 out of 52. So that's actually going to be 1 out of 13. And 1 out of 13. So we do 1 out of 13 plus 1 out of 13 is 2 out of 13. Okay, so this is going to require a bit of knowledge about fractions. Okay, so they are mutually exclusive events. Now, in example 2, the probability of rolling a 7 or an 11. Well, if I label this as A and this as B, let's take a look at what that means to have either a 7 or an 11. What kind of ways could we roll an A, or roll A, or 7? Okay, so we could roll a 3 and a 4. We could roll a 4 and a 3. We could roll a 5 and a 2. A 2 and a 5. We could roll 6 and 1. Or we could roll 1 and 6. So there's 6 ways to do that. Okay, so I have 6 ways to roll a 7. How many ways to roll an 11? Well, there's less ways to roll an 11 because we really only have 5 and 6 or 6 and 5. Okay? And so when we add up the probabilities of those two things, we really only have 6 out of 36 or 1/6, plus 2 out of 36, which is 1 out of 18. So we have 1 out of 6 plus 1 out of 18. Well, this is going to require us to know a little bit about fractions. Well, this is really 3 out of 18 plus 1 out of 18, which gives us 4 out of 18, which is 2/9. That's how these probabilities work. When we add up the probability of one plus the probability of another, those would be mutually exclusive events. Okay? So far we've talked about mutually exclusive events, but let's think about something where we'd have something where it wasn't mutually exclusive. So for example, let's say the probability of rolling 8 or doubles. Okay, so let's list the probability of rolling an 8 or double. So rolling 8 is going to be A, doubles is going to be B. So the probability of A happening is going to be listed by the sample space here. So we can roll an 8 in a couple of different ways. We could have 3 and 5, we could have 5 and 3, 6 and 2, 2 and 6, or we could have 4 and 4. Right? Those are the ways we can roll an 8. Let's think about the ways that we could roll doubles. This is not rocket science here, because the ways to roll doubles, we just list out all of the elements that could happen in there. So I'm at 5 and 5 and 6 and 6. So there's 6 ways to roll doubles, but there's 5 ways to roll an 8. But let's think for 1 minute. If we start to look at the comparison of these, they are not mutually exclusive events, because they could happen at the same time, because look at the overlapping event. So there is a way to roll both doubles and an 8. So how do we deal with that? The addition rule for probability says this. We're going to add the probability of A plus the probability of B, just like we talked about in the 2 previous examples. But what we need to subtract is the probability of A and B. Okay? Because what this does is it says we have the probability of A is going to be 1, 2, 3, 4, 5 out of 36. And the probability of B is going to be 6 out of 36. But if we think about this for just 1 second, we have an overlapping event in there, right? Because what we have is one that is counted twice, right? So the probability of A and B is going to be one event. So when we calculate the probability of A or B, it's going to be equal to 5 out of 36 plus 6 out of 36 plus the probability of A and B. So the probability of A and B happening is 1 out of 36, because there's only one thing that's going to happen. So we're going to subtract that. And I put a plus sign, but this should be subtraction minus 1 out of 36, because we've counted 4 twice. So we're going to subtract one of them because we don't need to count it twice. Okay, so what we end up with is 10 out of 36 or 5 out of 18. Okay, that's probability when we have events that are both mutually exclusive and not mutually exclusive. The addition rule applies to each. If you notice, we've subtracted the probability of A and B. Well, if you have a mutually exclusive event, the probability of A and B is 0, because they can't happen at the same time. So really the addition rule applies to all of these. It's just an extension when we have events that are not mutually exclusive. Okay guys, so thanks for watching. We'll catch you next time when we talk about the complement rules for probability. We'll see you next time.